let us see what is Maxwell Reciprocal Theorem. It states that let us consider 2 points, say I and j, of a beam. Let us say I is 1 point, j is point 2. It says that the deflection at point I due to the load applied at point j is equal to the deflection at point j if the load is applied at I. So to get better understanding, let me give the formula. So just now I have told the theory of Maxwell's reciprocal theorem. Now to get better understanding, I am going to use the formula. So here delta, the symbol indicates the deflection. So the deflection of the beam. Here I states that the deflection at point I due to the load applied at point j. So this is called delta ij. I repeat the pattern again. The delta ij indicates the deflection of a beam, that is the deflection at point I due to the load applied at j. So this delta ij will be or should be equal to the deflection at point j due to load applied at point I. So this is the theorem says. Okay. So now, we have seen what is Maxwell reciprocal theorem. We have seen the formula. Now we are going to take a beam to understand the Maxwell reciprocal theorem. So here we are going to take a simply supported beam. You can see here it has a rectangular cross section. So assume that the cross section of the beam is rectangular, having a breadth of B and depth of D. It has a length of L, and the beam is simply supported. So here I have shown a pinned support and a roller support. So now let us see, as I told earlier, we have to take 2 points, say point I, point J. So to show deflection delta Ij, here I have shown the schematic. So now delta Ij means the deflection at point I due to the load applied at point j. This is called delta ij. In the previous case we have seen what is delta ij. Now I am going to show the schematic to compute the delta ji. Again the same beam having a dimension of B and D, cross section, rectangular cross section, having a length of L. It is simply supported. So now we are going to see how to compute delta j. So now this shows the deflection at j due to the load applied at I. This is called delta j. So what I want to convey, delta ij is equal to delta ji. So by doing these 2 experiments, we can verify the Maxwell's reciprocal theorem. So let us see the tabulation, how to take the readings to verify the Maxwell's reciprocal theorem. So already you are aware about the hardware components. So we need to have a beam setup having simply supported, and we need to have a load hanger to apply the dead load, and also we need to have a data indicator to measure the deflection. So let us assume I apply a dead load of 1 kg at point I. So now I am measuring the deflection at point j. So while loading it shows 1.25 ohm, at unloading it shows 1.29 ohm. I will take the average. So for loading of 1 kg, we get 1.25 ohm as a deflection. Similarly, we can apply the second load, say 1.5 kg, and we will observe the readings accordingly. Is vice versa. Similarly, we will also do the case 2. We use the same tabulation to compute the delta ji. So by this way, we can prove the Maxwell reciprocal theorem, which is delta ij is equal to delta ji. See how to do the experiment, and we have recorded the readings, load versus load and deflection of 2 cases, delta ij and delta ji. Now we are also going to prove the Maxwell reciprocal theorem by plotting the graph between load and deflection. So here already we got the load values of 5 different readings. Also we have got the corresponding deflection values. So just plot the load value and deflection value, you will get a nice curve, a linear curve. So this curve will give the slope of that the slope of that case 1. So that is P by delta ij. So similarly, we can also plot the load versus reflection curve for the case 2 for the delta ij experiment. So and do the same, and you get P by delta ji. So the both slope would be equal. So again, by plotting the load versus reflection curve, it is possible to verify the Maxwell's reciprocal theorem. Thank you.
We have an experimental setup for verifying Maxwell reciprocal theorem. So we have a beam of 800 mm length and 12 millimeter wide, which is of 6 millimeter thickness. So this beam is placed over supports, which you can see on two sides, and then we have a weight holder wherein we can keep these weights such that load can be applied at that particular point. We have a magnetic stand with a dial gauge to sense the deflection. So the basic experiment is about load applied at one point which causes deflection at another point is being recorded. Later we will swap these two, and again we will do the same experiment by applying load at this point and measure deflection at the other point. So this can be tabulated, and we will have load versus deflection graph. We have to verify whether the slope of both the graphs are same, and then we can say that the Maxwell reciprocal theorem is verified.
எப்படி செட்டப் பண்ணலாம் அப்படின்னு எக்ஸ்பிளைன் பண்ணுறேன்.